Good day, everyone. Welcome to Richfield Hybrid Learning. My name is Silas Toperesu, and I'm your lecturer for Mathematics 512 module. Today, we're going to look at our syllabus topic 5, which is integration. On the learning outcomes of this chapter, upon completion, you'll be able to develop an understanding and ability to perform integration and other operations of certain types of functions. You'll also be able to develop a knowledge and a know-how on how to calculate a definite integral geometrically as the area under the curve of any function or a graph. You will also be able to develop a clear understanding of a definite integral and indefinite integral and the difference between a definite integral and indefinite integral. In addition to that, you also have a knowledge and a know-how on how to integrate exponent functions, logarithmic functions, as well as trigonometrical functions. Let's look at the definition of integration. Integration is defined as the reverse process of differentiation. Integration can be used to find areas, volumes, central points, and many other useful things in addition to finding the area under the graph of a function or the curve. We define an integration process as an antiderivative function. If fx is a continuous function and fx is a function whose derivative is fx, where fx derivative xf is given as f bar x, which is the fx as a result of derivative, then when we integrate our derived function or derivative, we are going to get our original function, which is fx, then we say plus c, where c is an arbitrary constant. So whenever we have got the result of our differentiation, if we need to reverse back our derivative to an original function, we reverse using an integration process. So when we integrate, we're going to get our original function where the derivation is original coming from. When we look at the concept of integral and differentiation, we have learned that, for example, for function y is equal to x squared, the dy dx, which is the differentiation of our function, which is dy dx, is equal to 2x in differentiation process. If we consider now the question that given y is a function and x, and then we are given the differentiation as dy dx equals to x, then the question comes and say, what is the function? Clearly, our answer will be the function. The function is y is equal to x squared. But is it possible for us to come up with only the function, which is y is equal to x squared, without knowing the original function, by only knowing the derivative? So that question now, we can actually ask ourselves, is this going to be the only answer, which is y is equal to x squared, which drives us back to when we differentiate, which gives us 2x? If we look back into our familiarity and experience with differentiation, we clearly see that all these answers that are below, which is y is equal to x squared plus 2, and y is equal to x squared minus 3, y is equal to x squared minus 4, y is equal to x squared plus 20, and in fact, y is equal to x squared plus c, which is an arbitrary constant. All these functions, when you differentiate them, they give us a derivative of 2x. So it's very difficult for us, when we are given only the derivative, to know the exact function, original function, which lead us to this answer, which is 2x, when we derived it. So with that in mind, or with that reason, it is very important whenever we are integrating for us to put a constant c, which way our c, which is an arbitrary constant, will represent any constant that might be in front of our function. Because when we differentiate this 2x, which we have got a constant plus 2, it gives us 2x. When we differentiate this expression, that is y is equal to x squared minus 3, which is a constant of minus 3, it also gives us 2x. So it will be difficult for us to know the exact function of where the derivative is coming from. So by this in mind, whenever we are differentiating, it is a good practice for us to put a constant of c as an arbitrary constant, which represents any constant that might be there in our original function during the differentiation. On symbols of integration, we know that when we're differentiating, for example, we're differentiating 2x squared, we represent with a d dx of this expression of 2x squared, and we are going to get 4x, because the differentiation will take the power, then we multiply, and then we minus 1 on the power. And when you're differentiating another function that you've got a constant, which is 2x squared plus 4 plus c, which have got constant, is also going to give us the same derivative, which is 4x. So these two functions, they are different, but they are giving us the same derivative, which is 4x. So when we are integrating, we use an integration symbol, which is this symbol, so meaning integration. So we're integrating our 4x in order for us to get the original function which we were having before we differentiate. So when we integrate 4x now, with the integration process, which is the reverse of differentiation, with the integration process, we need to add 1 on the power of x, and then we will divide with the total value of power. So here we've got x to the power 1. So when we integrate, we have to say 4x to the power 1 plus 1, and then when we say 1 plus 1, we're going to get 2, and then we divide by that 2. So we say plus 6. Immediately when we integrate, we need to say plus 6. So we end up having an expression which is 2x squared plus c. So our original function, which gives us, when we differentiate, which gives us 4x, is going to be y is equals to 2x squared plus c. In this integration of 4x dx, which gives us the value of 2x squared plus c, this type of integration, we call it an indefinite integral, because it doesn't have a limit. So whenever we integrate something that is in this form, we call it an indefinite integral, since it doesn't have a limit, lower limit or upper limit. So in the structure of this integration, we have got the symbol, which we call it an integral sign, and the expression that will be in front of our symbol, integration symbol, we call it an integrand. So any expression that is in front of our symbol that needs to be integrated, we call it an integrand. Then we also have a dx or a d variable, depending on which variable are we integrating in terms of. So if we have got another variable, let's say t, we will be actually having a dt in that, which indicates that we need to integrate in terms of x. So here we have got a dx, which represents the terms in which we're integrating our expression for that variable. So here we're going to get also our expression after integration, which is 2x squared plus c, which we call an arbitrary constant. So this is a constant of integration, and always c will be a value of a real number. When we are integrating any function or any expression which is in the form of k x to the power n, the general solution of integral of this form will be always indicated by integral of k x to the power n dx, where k and n are constants or values of real numbers. So the integral of such a function, we integrate by adding a 1 on our power of our variable. So we add 1 on x. Here we have the power of n, so we simply say n plus x to the power n plus 1. Then we divide with the total power of, after we add 1, which is n plus 1. Then we add our constant as c. So this becomes the solution of our integral of x to the power k x to the power n dx, where n is also not equal to 1 and c is a value of a real number. Here are some of the examples of solving indefinite integrals. So the example 1 says, find the integral of x to the power 7 dx. So when we're finding a solution of integral, solution of such an expression which is x to the power 7, the process of integrating, we need to add 1 on our power of 7 and say 7 plus 1. Then we divide with the total power. So we say x to the power 7 plus 1 divided by 7 plus 1 plus c. Always after we integrate, we need to add an arbitrary constant, which is c. So we end up having a solution of x to the power 8 divided by 8 plus c, where c is not is an element of what? Of a real number. So our example 2 is also said, find the integral of 3 divided by v squared dv. So when you are integrating such an expression that you've got a division, since we've got a constant on our upper as a numerator, we simply have to take a v to the power 2 up on the numerator, and you are going to end up having an integral of 3 v to the power negative 1, because always when you take a value from the denominator, the power of that value is going to change the status. So here we've got a negative, positive, a power of 2, and when it comes up to the numerator is going to be a negative to the power minus 2. So we end up having the expression of integral of 3v to the power negative 2 dv. Then we integrate with respect to v, since we have got a dv. So on the integration, we can take the constant, which is 3, out. Then we say 3 integral of v to the power negative 1. So now the process of integration, when integrating on the power, we need to add 1 on the power, and we divide with our results after we add 1 on the power. So here we are going to say 3, then we say v to the power negative 2 plus 1, and then we divide by minus 2 plus 1 plus c plus a constant. And every time, once we remove the integral sign, then we need to add a plus c, which is an arbitrary constant of our integration. So now we end up having a minus 3, which is 3 times v is going to be minus 3 divided by v, because v you are going to have left with v to the power minus 1. So to remove that v to the power minus 1, we take v down, then the power of minus 1 is going to change to a power of plus 1. So we end up having a result of minus 3 divided by v plus c, where c is an element of real number. Here is our third example of solving an indefinite integral. The question here is saying, find the integral of 16x to the power 3 minus 6x squared plus 10x minus 3 dx. So when we are integrating such an expression that you have got more than one terms, we need to integrate term by term in terms of dx. So here we are going to have an expression that is simply say integral of the first term dx minus the integral of the second term in terms of dx minus plus the integral of 10x in dx minus integral of 3 dx. So that's what it means. We need to separate each and every term, then we integrate term by term. So when we are integrating 16x cubed, we're going to have 16 times x. Since when integrating a variable, we need to add 1 to the power, and then we divide by the total number of power. So we're simply saying 16x to the power 3 plus 1 divided by 3 plus 1. So we divide it with the total power. Then we say minus. Then we differentiate our second term, which is 6x squared. We're going to add a 1 on our power. Then we're going to have 6x to the power 2 plus 1 divided by the total power, which is a 2 plus 1. Which is 2 plus 1. Then the third one, which is integral of 10x. 10x is the x to the power 1. So we're going to have 10x to the power 1 plus 1 divided by 1 plus 1. The third one also, we have got minus integral of minus 3, which is a constant. It means we have got x to the power 0. So we are going to have x3 minus 3x to the power 0 plus 1 divided by 0 plus 1. Then everything we say plus arbitrary constant, which is c. Then when we are solving our expression at the denominator, 3 plus 1 is equals to 4. Then 16 x squared divided by 4 minus 6x cubed divided by 3 plus 10x squared divided by 2 minus 3x to the power 1 divided by 1 plus c. So when you solve this 16 divided by 4, we're going to get 4x to the power 4. Then is 6 divided by 3, we're going to get 2x cubed. 10 divided by 2, we're going to have 5 plus 5x squared minus 3x plus c as our final results of our integral of the whole expression. Let's now look at the integration by substitution rule. If u is equals to gx is a differentiable function whose range is an interval I and f is a continuous on I, then integration of f gx g, a derivative of gx is equals to integration of f u du, where u is equals to gx. So, for example, when we have got an example that is saying find integral of x squared 3 minus x cubed to the power 4 dx. We check our first expression. If you check our expression, which is x squared is the result of the derivative of our internal expression, which is 3 minus x squared. So whenever we have got such a situation, we need to let u is equal to our internal expression, which is u is equal to 3 minus x cubed, and then we find the derivative of our du dx. When we find the derivative, we're going to get minus 3x squared, and when we find minus 3x squared, we need to find the dx. We need to make dx the subject of the formula, which means you are going to do cross multiplication and to find our dx as du divided by minus 3x squared. And now we now substitute finding the integral. When we put the integral x squared 3 minus x cubed to the power 4 dx, we are going to put u in place of 3 minus x cubed, and we put du divided by minus 3x squared on place of dx. So now we are going to end up having integral of x squared u the power 4 du over minus 3x squared, and x squared and this x squared here is going to cancel each other, and we are going to left with 1 over minus 3 integral of u the power 4 du. And now we can integrate the u to the power 4 in terms of u, and we're going to have u to the power 4 plus 1 divided by 4 plus 1, and then multiplied by minus 3, negative 3 in the denominator, plus a constant c, which is our arbitrary constant. And we're going to have our final result is minus, in bracket, 3 minus x cubed to the power 5 divided by 15 plus c, which is our arbitrary constant, is our result. Here's our second example of integration by substitution rule. The question is saying find the integral of x divided by square root of 1 minus 4x squared dx. So when we check the x can be the result of our derivative of our expression, which is on the denominator, which is minus 4x to the power 2. So now we can actually let u is equal to our expression, which is 1 minus 4x to the power 2. Then when we let u differentiate du dx in place of dx, and we're going to get du dx as minus 8x. And now we make dx the substitute formula to find our dx. So our dx is going to be du divided by minus 8x. So now the integral of x square root of 1 minus x squared, we change the square root. The square root is the same as to the power half. So when you put it to the power half and you take this expression up from the denominator, the power half is going to change to a negative. So end up having an integral of x 1 minus 4x to the power 2 to the power negative half. And now we substitute in place of 1 minus 4x squared and we put u, and then in place of dx we put du over minus 8x. We're going to end up having integral of x u to the power negative half du divided by minus 8x, and this x here and the x at the denominator will cancel each other, and you're going to left with 1 over negative 8 integral of u to the power negative half du. And now we integrate u to the power negative half, which means we're going to add 1 on the power, which is minus half plus 1, minus half plus 1 divided by minus half plus 1, and we're going to end up having our result as 1/4 u to the power half plus c, which is an arbitrary constant. And our final result, when we return the actual value of u, we're going to have 1/4 into bracket 1 minus 4x squared to the power half plus our arbitrary constant is our result. Now try to test your understanding by solving or finding the integration of each and every question here using an appropriate integration rule. Check on all the rules that we've covered so far to find which rule is applicable at each and every question. Let's now look at integration of trigonometric functions. The integrating formulas or main basic integration of trigonometric functions and rules that are applied in solving or finding the integration of other expressions or trigonometric functions are as follows. Integration of cos x dx is always equals to sin x plus c, and integration of sin x dx is equals to minus cos x plus c, which is our constant, and integration of sec squared x dx is equals to tan x plus c, and integration of cos x squared x dx is equals to minus cot x plus c, and integration of sec x tan x dx is equals to sec x plus c, and integration of tan x dx is equals to minus ln cos x plus c, and integration of cosec x cot x dx is equals to minus cosec x plus c, and integration of cot x dx is equals to ln sin x plus c, and integration of sec x dx is equals to ln sec x plus tan x plus c, and integration of cosec x dx is equals to ln cosec x plus cot x plus c. We can use integration formula table to find the rules that you apply whenever you are solving an expression, when we're finding the integration of a function or a trigonometric function. There is a rule, some of the rules that I've mentioned, which is the integration of sin x is equals to minus cos x plus c, integration of cos x equals to sin x plus c are here in our integration formula table. We can also use to check also the differential rules that are here, as we know that the integration is the reverse of differentiation, so you can check the rules for differentiation as well in our formula table. So whenever you are solving an expression, we can check the rules on the integration or differential table. Let's look at an example of trigonometric function. Here the question said solve integral of cos 5x plus 3 dx. So solution here when we are solving such an x, if we check on our rules, we've got the integral of cos x x. Then but here in front of our cos x, we've got an expression that is 5x plus 3. So whenever we have got a big expression like this, we need to let u is equals to, we use the substitution rule, then we let u is equals to 5x plus 3. Then we solve du dx is equals to differentiate our expression that is in front of our trigonometric function. And then when we differentiate this, we are going to get 5. And then we make dx the substitute formula, then we find our dx as du over 5, and then now we substitute in our function, when in our integration of cos 5x plus 3 dx, in place of 5x plus 3 we put u, and in place of dx we put du over 5. Then we are going to end up having integral of cos u du over 5. So we take 1 over 5 outside the integral, then we are going to have 1 over 5 cos integral u, and we know that cos u is equals to sine u from the rules that cos x is equals to sine x. So we know that cos u is equals to sine u. So end up having the result of 1 over 5 sine u plus c, which then we return the actual value of what of u, which is 5x plus 3. Then our final result is going to be 1 over 5 sine 5x plus 3 plus constant c, which is arbitrary. Here is our second example of solving a trigonometric function. The question is saying solve integral of cosec 4x minus 3 tan 4x minus 3 dx. So solution, since we have got an expression in front of our trigonometric function, which is actually not an x, so we can let u is equals to our expression, which is 4x minus 3. And when you differentiate using a substitution rule, this is a substitution rule, we find du dx. When we find du dx, we're going to get 4, and then we make dx the substitute formula, we're going to get dx is equals to du over 4. Then in our original expression, which is integration of cosec 4x minus 3 tan 4x minus 3 dx, we substitute in place of 4x minus 3, we put u, then we are going to have integration of cosec u tan u dx. Then on place of dx now we have to put du over 4. So we're going to have integration of cosec u tan u du over 4. Then we factor out 1 over 4 outside our integral. Then we're going to have 1 over 4 integral of cosec u tan u du. And from our formulas, integral formulas, we know that cosec u is cosec x tan x is equals to sec x. So cosec x tan x is equal to sec x. So now in place of cosec u tan u, we know that our integral of cosec u tan u is equals to sec u. So now we have got a 1/4 sec u plus constant c, and now we return the actual value of u. The actual value of u, which is 4x minus 3, we put in place of u. We're going to have our final integral result as 1 over 4 sec 4x minus 3 plus constant c. Let's now look at our third example for solving trigonometric function, which says solve integral of sine x squared dx. So using an identity rules of trigonometrical, such as sine x, from identity rules we know that sine x squared plus cos x squared is equals to 1, and also sine squared x is equals to 1 minus cos 2x over 2. So in place of sine squared x, you can put 1 minus cos 2x over 2. So here you can substitute our integration of sine x squared dx as is equals to integration of 1 minus cos 2x over 2. So we factor out this 2, which is our denominator, and we're going to have half integral of 1 minus cos 2x dx. So we solve the integral of these terms one by one. So we're going to have an integral of 1 minus integral of cos 2x dx. So integral of 1, we're going to get, we'll factor this half is outside, so integral of 1 is equals to x, and integral of cos 2x, we're going to get differentiate the function that is in front of our cos, which is 2x, and we get 2, and then we integrate the constant of cos from our trigonometrical rules of integration of cos is equals to sine. So we're going to have sine 2x divided by 2, which is the derivative of our function that is in front of the expression. So now we multiply with our outside half, then we multiply each and every term, we're going to get half x minus 1/4 sine 2x plus a constant, which is arbitrary, as our final result of the integration of integral sine x squared dx. Let's look at integration of exponents and logarithms. We have seen that the the derivative of exponent function is quite easy. The dx of exponent x is equal to exponent x, and the integration of exponent x, which is the reverse of differentiation, the integration of exponent x in terms of x is equal to exponent x plus c. And also another rule for integration, when you are integrating a constant to the power a variable, which is a constant to the power x dx, is equals to a constant to the power x divided by ln a constant plus c. So whenever you are integrating any constant that you have got the power variable, we use also this rule, that is simply say the result is the constant to the power x to the power variable divided by ln a constant plus c. Let's look at an example for differentiating an exponent with the question that is saying find the integral of exponent power 3x plus 1 dx. So in this expression, since our power of exponent is a function, we can let u, using substitution rule, can let u is equal to our function of our power, which is 3x plus 1. Then we find du dx. When we differentiate this expression, find du dx, we're going to have our du dx as 3. And now we need to make dx the subject of the formula. Then our dx is going to be our du over 3. And now in place of our function, we are putting a u. So in our original function, that is the integration of exponent 3x plus 1 dx, we're going to put a u in place of 3x plus 1, and we're going to end up having integration of exponent u du. In place of dx, we put du over 3. Then you are going to take out 1 over 3 outside the integrand. You're going to have 1/3 integral of exponent u du. And from our rules of exponent, we know that the integration of an exponent u is equal to exponent u. So our result is going to be our 1/3 times exponent u plus c. Then we return the actual value of u, which is 3x plus 1. Then we are going to have our final result is exponent 3x plus 1 divided by 3 plus c as the integral of exponent 3x plus 1 dx. Here is our second example, which says find the integral of 6 to the power 5x plus 1 dx. So here we're finding the integral of a constant to the power function. So we let u is equal to our function, which is the power. So when we let u is equal to 5x plus 1, we're using the substitution rule. We then find the derivative of du dx. So du dx, when you differentiate 5x plus 1, we're going to get 5. And now we make dx the subject of the formula. Then we're going to get du over 5. In our original function, which is integral of 6 to the power 5x plus 1 dx, in place of 5x plus 1, we're going to put u. So we end up having integral of 6u. So in place of dx, we're going to put du over 5. Then we're going to have du over 5 in place of dx. So we factor out 1 over 5, and we're going to end up having 1 over 5 integral of 6u du. So according to the exponent rules, 6 integral of 6x, 6 to the power x is equal to 6 to the power x divided by ln constant, which is ln 6. So this integral of 6u is going to give us 1 over 5 ln 6 to the power u plus c as our result. And now we return the actual value of u, which becomes 6 to the power 5x plus 1 divided by 5 to ln 6 plus c as our solution for this integration of a function. Let's look at the integration of logarithmic functions. As we know from differentiation, the differentiation of ln x is equal to 1 over x. So the integration, which is the reverse of differentiation, when we integrate 1 over x in terms of dx, our result is going to be ln x plus c, which is our arbitrary constant. Here is an example 1 that says find the integral of x divided by x squared plus 1 dx. So when we're differentiating such a function, we need to use the substitution rule. When we use the substitution rule, we let u is equal to our denominator, which is x squared plus 1. Then when we differentiate our function du dx, we're going to differentiate x squared using the power rule. When we use the power rule, we take the power, which is 2, then we multiply by x, then we subtract 1 from the power. So we end up having our result of derivative f 2x. Then we make dx the subject of the formula. When we make dx the subject of the formula, we cross multiply. then we are going to find our dx as du over 2x. And then in our original derivative function, integration function, which is x over x to the power 2 plus 1 dx, we put in place of our function, we put our u. So we're going to have integration of x over u. In place of dx, we're putting du over 2x. So we're going to have integration of x over u du over 2x. And this x on the denominator and x on the numerator is going to cancel each other. And then we factor out a half that we have. Then we're going to have half integral of 1 over u du. Then in terms of logarithmic integration laws, 1 over u, when we integrate 1 over u, we're going to have ln u. So our result is going to be half ln u plus c, and then we return the actual value of u, which is x squared plus 1. Then we are going to have 1 half ln x squared plus 1 plus c, which is our constant. Let's look at the second example, which says find the integral of 5x to the power 4 x to the power divided by x to the power 5 minus 3 dx. So when we look at our denominator, the differentiation of our denominator, our numerator is the result of the derivative of our denominator. So now we have to use the substitution rule. We let u is equals to our function on the denominator, which is u is equals to x to the power 5 minus 3. Then we differentiate du dx. When we differentiate du dx, we use the power rule on x to the power 5. Then you take 5, then we multiply by x and say power 4 minus 1. So we're going to have our du dx as 5x to the power 4. So now we need to find our dx. Dx, we need to cross multiply and make dx the substitute formula. So our result is going to be du over 5x to the power 4. And now in our original integral or function, which is integration of 5x to the power 4 divided by x to the power 5 minus 3 dx, we're going to substitute our function, the denominator, with our u. So we're going to have integral of 5x to the power 4 divided by u, and in place of dx, we're going to put du over 5x to the power 4. Then now, if you check our denominator, we have 5x to the power 4, and our numerator, we have 5x to the power 4. So these are going to divide each other, our denominator and numerator. So we're going to have a result of integral of 1 over u du. So according to our logarithmic laws of integration, integral of 1 over u is equals to ln u. So our result is going to be ln u plus c constant, and then we return the actual value of u, which is x to the power 5 minus 3. So we're going to have our final result as ln x to the power 5 minus 3 plus c, which is arbitrary constant, is our result. Here are some of the exercises to test your knowledge and understanding. Solve the following questions, find the integration of each and every question, apply the appropriate integration rules, refer to the previous examples that we have covered so far in order to understand which rule to apply at each and every question. Now we come to the end of our chapter 5 lecture for today. Thank you all for being part of Richfield Hybrid Learning Program. I wish to see you all in our next lecture.